Let's say I asked you this math problem. I said, okay, here's a word problem for you. Assuming that gas costs $1.50 a liter, how much does it cost to fill up your tank of gas? And you might say, well, that's a pretty unfair question here. You're asking me to tell you the answer, but I could actually answer this if I knew how many liters there were. So really, your answer to me would be more of a question. It would say, well, the answer to your question, sir, is that it's going to depend on how many liters of gas you need. All right, well, let's say if I asked you this question, let's say assuming the small score bar blizzards cost $4.50 each at Dairy Queen, how much does it cost to buy all your cousins' small score bar blizzards at Dairy Queen? If you think about the question for a while and you're trying to do a calculation, realize you can't do a calculation. You say, sir, I can't answer this because the answer is going to depend. It's going to depend on how many cousins you have. If I know how many there are, I can multiply that by 450. But if I don't know how many cousins I have, then I can't answer it. Let's do another example. Let's say Giovanni's got 40 packs of Skittles in his backpack and he eats 4 packs of Skittles every hour he's on the plane. How many packs of Skittles will he have left when the plane lands? And again, you're trying to do the problem. You're looking at the numbers. You got 40 packs and 4 packs every hour. Okay, let me figure this out. The answer is it's going to depend on something else. It's going to depend on how long the plane's flight is, and also depends if he's going to manage eating all those Skittles. So what we're looking at here are questions where we actually have an answer that will depend on another piece of information. Really, we can look at this a little bit later as involving two variables. It's a relation between two changing quantities. One quantity changes, and that makes another quantity changes. One number changes, that makes another number change. To give you an example of what we're talking about when we talk about these relations between numbers, between variables here. Here, look at the left, you see this thing here is a relation. A car travels 25 kilometers for every hour you drive. As the number of hours changes, then the total number of kilometers that you drive changes. Those two numbers change together. There's a relation between them. They change together. Over here, if I just say that a car travels 25 kilometers, then there's no change that goes on. The distance that the car travels doesn't change. It's just 25. That's the whole story. That's the whole thing. It's not going to travel more if something else changes, if there are more people in the car or anything like that. It's just 25 kilometers. So this isn't a relation between two numbers that are affecting each other. Look at another example here. If Mark pays $2.50 for every 500 sheets of paper, then the total amount that Mark is going to change, that number is going to change when the total number of sheets of paper changes. That makes it a relation between two variables, two things that are changing at the same time and affect each other. On the other hand, if I just tell you that Mark buys 500 sheets of paper, then there aren't two numbers, two quantities that are changing with each other. It's just a flat 500 sheets of paper. That's the whole story. No relation going on at all. Okay, what about this one? Mary earns double the amount of money that Sebastian earns. You'd say to yourself, if I asked you how much money does Mary earn, you'd say, well, that depends on how much Sebastian earns. If Sebastian earns more, then Mary earns more, right? She'll earn twice as much, no matter how much Sebastian earns. On the other hand, if I had a situation like this where I just know that Mary earns $10,000, there's no change going on there. There's no way that $10,000 is affected by something else going on, right? If in the story on the right, there is no guy named Sebastian. There's just Mary and her $10,000. And if Mary has 3 dogs or 4 dogs or 5 dogs, that doesn't change anything about the amount of money she earns. There's no connection between two numbers. You look at this example. Marcus takes 10 minutes more than Alex to do his homework. Okay, we know that Alex takes 20 minutes, then we'll know Marcus takes 30. We know that the amount of time that Marcus takes depends on how long it takes Alex. On the other hand, if I just tell you that Marcus takes 25 minutes, there's no connection between two numbers. There's no relation going on here. The amount of time that Marcus takes doesn't depend on anything else. The whole story is just Marcus takes 25 minutes to get his work done. Now, this is a slightly different example in that we've got a story here that doesn't involve the same kind of narrative like we've seen, but we've still got one number on the left that's actually changing the story with what happens on the right. If you look at this, you can see how it makes sense, right? As the amount of time, the number of minutes increases, this is more time is passing. Here, if we're looking at the temperature of a cup of coffee, it would make sense that as time passes, the temperature goes down, it cools off, right? The temperature of the cup of coffee depends on how much time has gone by. More time goes by, the coffee would get even cooler if we kept this chart going on further. But over here, if I just tell you that right now the temperature of a cup of coffee is 47 degrees Celsius, the story I'm telling you doesn't involve a relationship between two things. This is the whole story I'm telling you, and that's all you've gotten. It's not connected to another number that will affect it. All right, let's try and put this idea to the test, see if you can figure these out. So let's look at each of these examples, decide if they're relations. Here I've got a story where my car burns 6 liters of gasoline for every 100 kilometers it travels. Well, relation, no relation, what do you think? Yep, this is a relation because I've got one quantity, the total number of kilometers that gets traveled, that'll affect how many liters of gasoline get burned, right? The longer that this car travels, the longer distance it travels, the more gasoline gets burned. That is a relation, okay? Let's look at another one. Let's say I spend $12 on candy. Is this a relation or no? The answer is no, right? It could be turned into a relation if I start giving you more information about how the total amount of money is affected by specific candy. Like, let's say I'm talking about bars of chocolate, and each chocolate bar costs $1. I could say that the amount you spend, the number of dollars you spend is directly related to the number of chocolate bars you buy, right? That would be something like, for each chocolate bar that you buy, you spend $1. That would be a relation, but this example is not. It's just a flat story. I'm given only one number. It doesn't depend on anything else. Let's look at this example. Would this be a relation? Jennifer earns $55. Just like that, it doesn't constitute a relation. There is no connection here between two numbers. It's just a flat piece of information. One number not connected to another, not connected to any other quantity. The same story could be a relation if I said something like, Jennifer earns $11 for every hour that she works. Then the number of hours goes up, then the amount of money goes up. But just like this is not a relation. What about this one here? Jennifer earns $2 less than Celine. Is that a relation or no? It is, right? The amount of money that Celine makes will tell us the amount of money that Jennifer makes, right? For some reason, Jennifer earns $2 less than Celine. So if Celine makes $20, Jennifer earns $18. The amount that Jennifer earns depends on the amount that Celine earns. Okay, what is relation? What is this that we're getting at? To put it formally in terms, it's a comparison between two quantities. Really, it's a relationship between two quantities. And they typically, always, they're going to contain two variables in the examples we'll look at. You can actually have more than two variables, but we'll only be looking at two. And the variables are unknown quantities, right? This can be a little tricky to get a handle on at first because you'll see a number and you say, well, a number can't be a variable. But the number is usually going to be multiplied by the unknown quantity. We'll see some examples of that in a second. A relationship between the variables has to exist. So you can't just have the two variables floating around with no connection to each other. There has to be a connection between them for it to be a relation. Some examples we've seen. They can show up in words like we've seen. A car travels. I know it says a car is travels, but you know what I mean. A car travels 50 kilometers every hour it is on the road. So you might look at this and say, well, 50 is a number. That can't be a variable. You're right. 50 kilometers here isn't the variable. And it's important to recognize that the kilometers here is not the variable. What is a variable is the number of hours that the car is on the road and the total number of kilometers that it travels. So the 50 isn't a variable. The total kilometers is, and total kilometers, that number, which we don't know, is going to depend on how many hours it's on the road, which we also don't know. So those are the two variables here. You see the connection between them is that every time your number of hours goes up by 1, the total number of kilometers is going to go up by 50. That's what makes it a relation. Okay. Here's another this is just explaining first variables, the time the car travels, second total distance it travels. Okay. You can also see a relation as a graph. Look at this here. This is a relation because there's two things that are changing here, two unknown quantities, two variables, and there's a relation between them. This example here, as the number of hours goes up, the total money that Daniel earns also goes up, right? There aren't numbers on here along this line, along the x-axis here. There's no scale indicated. But you can see generally that if there were numbers, as these numbers are getting bigger and bigger, like if this is 0, this is 5, this is 10, this is 15, this is 20, every time I look at a bigger number, 5, 10, 15, and I look at what the y-axis would be telling me, I see that I'm getting greater numbers the further along I go in time. So this is a relation. We see a connection shown in this graph, and we'll see a lot more of these in the coming weeks, between the amount of time that's worked and the total money that Daniel earns. In this case, the variables we mentioned are time and the total money that Daniel earns. We don't know what either of those are. They don't have specific values, but we can see the relationship between them. We can also see relations in what we'll be talking about as tables of values. A table, we used a lot of tables in the last unit. A table of values is really just a set of ins and outs, like with the coffee example, right? Like this example here, it's saying the amount of time, if we put the amount of time that somebody's worked in one column, then that tells us the information that'll pop up in the second. And this is a relation because, again, we've got two variables showing here. The two variables are the amount of time worked and the amount of money earned. And we don't have a set value that we know for sure. We don't know how long whoever this is worked, but we know that if they were to work 0 hours, the amount of money they would earn would be 0. If they were to work 1 hour, then the amount of money they would earn would be $15. So it is relation that as this number goes up, this number is going up by a set amount. Here's another example, and this we'll be getting to much later in the unit, but I want to give you a sneak peek on it so you can sort of see how a relation can show up. It's not just in words, it's not just in graphs, it's not just in tables, but it's also, and this is critically important, as an equation. This right here, y equals 5x minus 3, this is a relation between two variables, right? The two variables here are x and y. In this example, we're talking about the mass of the water involved here being x and y representing the volume of water. So this would be some very strange arrangement where this would happen. But we don't have a set amount of volume of water that we know. There isn't only one answer to this. The amount of water is going to depend on what number you throw in for x. If x is 0, then I'm going to do 5 times 0 minus 3. Somehow I'm going to have volume of minus 3, which doesn't really make any sense in this example. But anyway, if x is 1, then y is going to be 2. If x is 2, then y is 7. X is 3, y is 12. Now, I did that fast. We'll get to that later on. But I want you to understand here that this is a relation between two variables where we can understand the connection between them, and as one changes, the other changes. There is no one single value for x. There's no one single value for y. Instead, we have a relationship between the two, and that's what's important here.